But whenever we are taking our antenna, that our TV antenna mounted on our roof came into our mind. Okay, so it is not only like that. So what is antenna? If someone wants to send a signal from one place to another place wirelessly, okay, the thing is wirelessly, he need a component that is antenna. Okay, and similarly it can be, a signal can be transmitted from one place to another place wirelessly through antenna, and through antenna it can be received also. Okay, so antenna is needed at both end, at the transmitting end as well as the receiving end. Okay, so someone is coming. Okay, so you can think how much important this component is. Okay, in today's scenario, all of us are moving for the wireless technology, and you can think without antenna we cannot send the signal from one place to another place wirelessly. Okay, so for sending any signal, antenna is necessary in every device which you are having in your home, in your car, and in your office and in your daily life, which is working on the wireless scenario. Okay, we are not talking about the laser, because laser is another application. In laser technology we are not using the antenna, but if you are sending the signal from one place to another place and you are receiving it, then you are using an antenna. Okay, in your mobile phone you are using Bluetooth signal, you are using 2G, 3G, 4G. Okay, and in the later stage 5G will also come. And in other things, means you are using Alexa, means okay Google type devices. Then in such type of devices, antennas are also being used. If you are traveling in your car, then you are receiving the signals, you are using the GPS. Okay, so all these things are possible through the antenna only. Okay, so in the several industries antenna is necessary. So there is always a question, how can EC engineer can accommodate themselves in the industry. So antenna industry is also a big option which is not hugely available in India, but if you will explore the various company of the antenna working in the antenna field, then worldwide there are several lot of MNC companies who are solely working in the antenna component. Okay, and what is the other benefit? If you are doing the research in the antenna, then you can also accommodate yourself in the other microwave component. Means you can do your work in the filters. Microwave filters are also there. You can do the work in the amplifiers. Power amplifier and low noise amplifier are also there. Okay, so you can accommodate yourself in various technology if you are working in the antenna. But in this subject we will talk only about the antenna. Okay, so the importance of this subject as well as this component, I have cleared this thing. And if you are having any doubt, you can ask immediately. Okay, so if we will look about the antenna definition, so according to the Webster dictionary, in the uh, in the initial stage, it was considered only as the metallic device, or means you are using a simple wire. Okay, so earlier it is considered only as the antenna can be used as the metallic component should be there, metallic material, conducting material should be there. But nowadays this definition is changed slightly. This definition has been changed slightly. We are also using the DRA, dielectric resonator antenna. Okay, so this definition, first definition, usually a metallic device as a rod or wire for radiating or receiving radio waves. Okay, if you will find out this antenna word in your dictionary, then you will find this definition. Okay, but now we are doing our research, we are moving towards the development of research, so this definition has been changed. Okay, so if we talk about the IEEE standard definition, then we can define the antenna or aerial as a mean for radiating or receiving radio waves. Okay, this definition is correct. Means if we want to radiate some EM signals, electromagnetic signals, then we need a device. The name is antenna. And similarly, in the vice versa mode, receiving antenna, if we want to receive the electromagnetic signal from the free space and we want to regenerate it, we need an antenna. Okay, means you can think what it is doing, what the antenna doing. And if we talk about at the transmitting end, it is converting a type of energy into the another type of energy. Means in transmitter side you are having your signal generator and something, means you have done several things, means modulation and amplification you have done. Okay, so now you are having the electrical signal. Okay, and you want to transmit that electrical signal, means you are having a sine wave or sinusoidal type wave. Okay, and you want to transmit this electrical signal into the free space. And what would be the type of energy in the free space? That would be the EM energy, radio wave, electromagnetic energy. Means you need a device which can convert one type of energy into the another type of energy. Means at the transmitting end you need such a device which can convert the electrical signal into electromagnetic signal. Okay, and what such type of device is referred as, that is the transducer. Means we can say antenna is a transducer which is converting the electrical signal into the electromagnetic signal at the transmitting end. And if we talk about the receiving end, it is converting the electromagnetic energy into the electrical energy at the receiving end. Okay, so this is the simple definition. We can think technically what is antenna. Antenna is basically a transducer. But if we will talk about the technical things and about a layman thinking, means you have seen several people are connecting their radio with a simple wire, and that simple wire is working as an antenna. Okay, so we are the engineer, we are the technical person, we have to think what is the technical phenomena, what is the technical mechanism going behind this activity. Means someone is connecting simple wire and it is working as the antenna. Okay, so if you will see that some remote cars is also there, I'm looking for a toys of my child, but it is not nearby me. So okay, you will see there is only a wire, and let me take that thing. I'm just coming. 1 minute. Okay. Yes, you can see on my video. This is a car remote, and you can see here. This is the antenna. Okay, so what is this antenna? What is this doing? Okay, so if we will talk about the industry part and if we will talk about the other parts, it is a very wide scope. Okay, so we will talk what is the technical phenomena are there. Okay, so let's move ahead. This is a type of conventional antenna. You can see it is looking like your antenna in early days, which was mounted on your roof, and you rotate that antenna rod and call someone who is sitting behind your TV, and you are asking whether signal is coming or not. But this is not that antenna. That was the TV antenna, which was mounted on your roof for the TV signal. That is Yagi Uda antenna. Yagi and UDA was two scientists, YAGI and UDA. Okay, this is a picture of log periodic antenna designed in the HFSS. Okay, so such type of antennas were there. Okay, so even in your syllabus, log periodic designing of log periodic antenna is also there. Okay, so this is the phenomena. Basic phenomena is this. You can see this box is representing your transmitter part. Okay, and here from this portion, let me change my marker. So this is the transmitter part. Okay, and from this is the antenna structure. Here it is mentioned antenna structure is starting from here. And what is this? This is the transmission line. This is the transmission line. So all of us are known with the transmission line. What is the transmission line? Transmission line is just a medium which is used to transmit a signal from one place to another place. Okay, several type of transmission lines are there. Means coaxial transmission lines are also there, two wire transmission lines are also there, microstrip line, which you have designed in your EMT syllabus, that was also a type of transmission line. Waveguide, rectangular waveguide you have studied, and in this microwave, your microwave course is also running parallelly. Okay, so that is also waveguide is also a type of transmission line. Okay, so several type of transmission line we can use. So we are just having a transmitter, okay, and an antenna, and this is the physical medium which is connecting the transmitter with the antenna. Okay, and this is the antenna structure. Okay, and this is the radiated radio waves. So what is antenna is doing? Antenna is working as the transducer which is converting the electrical signal. Here you can see electrical signal is there. Okay, a sine wave is there. Okay, if you will talk about any signal, then it is moving in the shape of sine. Okay, and when the antenna structure is started, then you can see some tilted arrows are there. Okay, so means you can say the signal is resonating. The signal is resonating. Okay, and the condition of resonance, you are aware with that. Condition of resonance is dependent on the L and C part. Okay, we will discuss all these things in detail with this subject. Okay, so means at this point you can think a signal is coming from the transmitter and going through the transmission line, and whenever an antenna structure is there, okay, it is like it is resonating there, and whenever a discontinuity is occurred after a particular length, the field is radiated. The field is radiated. Okay, we will discuss this thing in detail in later slides. So what is the radiation mechanism? This slide is telling you what is the radiation mechanism. Okay, we are going to discuss what is the radiation mechanism in detail. So I have told you, after a particular length, after a particular distance, whenever a discontinuity is occurring, the radiation takes place. Okay, so discontinuity have an important role. Discontinuity have an important role to achieve the desired radiation. To achieve the desired radiation. Okay, and second thing which I have talked, after a particular length means at which position you need to integrate that discontinuity within your antenna structure. That will also a major concern. Means discontinuity at a particular length will be responsible for the radiation. Okay, so let's see what I am talking. If anything is unclear, you can ask your doubt immediately. Okay, so these are some mathematical equations. Whenever when I was a student, then I I didn't like such type of equations, but now I'm comfortable with this equation. Okay, so I will explain these equations so you will also comfortable like me. Now I'm comfortable, then you will also be comfortable with these equations. Okay, so this is the simple form of current continuity equation. You can say, okay, what is this? So first of all, we will see this equation. Okay, what is this? Suppose this Q charge, and here it is mentioned as QL. L is denoting a length. Okay, L is denoting a length. Suppose there is a rod, conducting rod is there. A Q charge is moving with a velocity Vz. Q charge is moving with a velocity Vz. Z is denoting the direction, L is denoting the length. L is denoting the length. Okay, Q charge is moving. V means velocity, means it is moving. It constitutes a current I. All of us are known with these simple words. Q charge is moving with a velocity V. It constitutes a current I. Okay, all of us are aware with this thing. Okay, and similarly, this is the line charge. Okay, this is the line charge. If we are having the surface charge, then there would be a surface charge density, and jz is also comparable with this line charge. Okay, in this is also the similar equation. In this situation we are not having a rod, we are having a sheet of zero thickness, tends to zero thickness. Okay, a sheet. Okay, and qs means q charge is moving with a velocity v, and it constitute a current j. And here now j is denoting the current density. What would be the current density? If we are talking about the surface current density, then that would be the delta I over delta s. Okay, and what is this? This is the volume current density. Means now we are having a sphere or a 3D body, not the sphere. We can also have a cuboid. Okay, means we are having a volume, and now we are having the QV charge moving with the velocity Vz. It constitute a current, and this is the volume current density. We are talking about the current density. Okay, so these three equations are very simple, all of three, in which in this one we are talking about the volume charge and volume charge density. If volume charge is moving with a velocity v, it constitute a volume charge density. Okay, it is also comparable with current I. If we are talking about the surface charge, and surface charge is moving with a velocity v over a sheet, then it constitutes a surface charge density. It is also comparable with I. Okay, and the simplest form, familiar form, is q charge is moving on a rod, on a wire with a velocity v. It constitutes a current. Okay, so these are simple equations. Okay, so take it most familiar equation. Okay, so what is this? Q charge is moving with a velocity v. It constitutes a current I. Okay, now I am saying this charge is accelerating or de-accelerating. This charge is accelerating or de-accelerating over the length L, Okay, so what I said, this charge q charge is accelerating, means v would be time varying, means I can say dv by dt. What is this? This is the acceleration. This is the acceleration. Okay, so what I am doing, I am differentiating this equation with dt. Okay, means I'm saying this q charge is accelerating. Okay, means you are having a time varying current. You are having a time varying current. What is the time varying current? This is a very difficult word, time varying current. Okay, but you are also having a familiar word, sinusoidal. Okay, time varying means if we are talking a time varying current means we are having such type of signal which is varying with respect to time. Okay, so you should always visualize the mathematical equations, then it will become very easier to you. Once you are reading or once you are observing any mathematical equation, it should be floating in your mind like a wave, like a waterfall, and any beautiful thing which you can understand easily. Okay, so what is this? Q charge is accelerating over a length. Okay, and it is constituting a time varying current. Okay, now we are putting this L factor. L factor is the length of your wire on or your antenna. Okay, so this length is very important factor. We will discuss in the same class. In today's class we will discuss how L is affecting the things, but now take this thing. So what is this equation? What is this equation? We can say we are just multiplying L on the LHS and L on the RHS. Okay, what we are doing, what we are saying, Q line charge is moving or is accelerating with this acceleration. In this equation you can say Q charge is accelerating over a length L and it constitute a current, it constitute a time varying current. It constitute a time varying current which is running over the length L, over the length L. Okay, and this is the condition, this is the condition for the radiation. This is the condition for the radiation. Okay, so you can say, you can see two things are majorly involved here. Two things are majorly involved here. One thing is the length, one thing is the length, and second thing is the time varying current. Time varying current. Okay, so we can conclude this discussion, we can conclude this equation. One thing is L. L is mandatory. How L will define the radiation characteristics. Okay, so you can take it as a concept. You can take it as a concept. Suppose you want to radiate a signal of 2.4 gigahertz. Okay, so you need to calculate a particular L physical dimension according to that frequency. Okay, for the second example, now you want to radiate a signal at 5 gigahertz. So you have to take your L dimension, length of the antenna according to your working frequency. Okay, so one thing is the dimension of the antenna, length of the antenna, and second thing the acceleration means time varying field, time varying field. Okay, and one time it was asked in your gate exam, and that was a very confusing question, and the crux is because they put the confusions by their language. The crux is the final thing is, if you are having a direct current and if you want radiation from an antenna and you are applying direct current, then radiation is not possible. Okay, so the thumb rule is for the radiation, the current should be time varying. The current should be time varying. Okay, so you can recall your block diagrams of your communication systems. I think you have studied the digital communication also. Have you?
Yes, sir.
Yes. So digital communication system. Tell me one thing: why we are using the digital uh, digital systems? Why we want to digital systems?
Because sir, it's
So
easy to transmit and
easier to store as well.
Easy to store, one thing. Okay. Second thing means security purpose. Security is high. okay, and transit time within the device is high. Okay, so there are so many advantages of the digital communication systems. Okay, but okay, so if I will talk about the digital communication systems, and if I will talk about not in the depth, but I will talk only about the block diagram. Okay, block diagram of the digital communication system. So there would be a signal generator, or means you can receive the signal from your mouth, that may be the analog signal, and finally after using a transducer you are having an electrical signal, and then you have modulated that thing, and you have applied the digital techniques, and now you have converted your analog signal into the digital signal. Okay, but before transmission, please listen this thing very carefully. But before transmission, you are applying ASK, PSK, FSK. Why? First of all, you are having the analog signal, okay, in your digital communication system. Okay, and at the end you have applied the digital techniques, you have converted the your signal into digital channel. Okay, encoded your signal, modulation is there. Okay, but before the transmission you are using the ASK, PSK, FSK. Why you are doing that thing?
Sir,
Means, हाँ दक्ष, मैं एक बार और मुझे बाकी को समझा लेने दो। मीन्स मैं देखो क्या बताना चाह रहा हूँ आप लोगों को। आपका जो डिजिटल कम्युनिकेशन सिस्टम था, आई एम स्पीकिंग एनालॉग सिग्नल, okay, you want to transmit this thing, means you have converted this my voice by the mic. Okay, and now you are having an analog signal, analog electrical signal. Now you have applied the digital techniques to take the advantages of the digital signals, but before the transmission, before the radiation, before the transmission, you again use the ASK, PSK, FSK. Why you are doing so? Daksh, batao.
sir, I mean, it's the main goal of the digital modulation, I think, is to squeeze as much data in as minimum bandwidth as possible. And that's one of the goal. And the
Yes,
other
but
goal, I guess, was that we had to.
I'm asking why we are using the ASK, PSK, FSK. Okay, let me tell you. What is we are doing with the ASK, PSK, FSK? We are just converting our 0110 sequence into the analog signal. Okay, the same thing is happening. Okay, earlier we are having the bit, we are having the encoded signal. Then by using ASK, PSK, FSK, we are converting again the digital signal into the analog signal. Why we are doing so? Okay, समझ गए ना? सबसे पहले first of all I am having my voice command, that is a analog signal. Okay, it is converted by a transducer. You can see the example mic I am using. Okay, now we are having the electrical analog signal. Electrical analog signal is there in your system. Okay, now you have applied the digital techniques, you have converted it into the digital technique to take the various tremendous advantages of the digital systems. Okay, but before transmission you have applied shift keying methods, ASK, PSK, FSK, QPSK, MSK. Okay, again after using this ASK, PSK, FSK, you are converting your digital signal into the analog signal, into the analog signal. Okay, then you are transmitting your signal through the antenna. Okay, question is clear? मीन्स हम लोग ASK, PSK, FSK यूज कर रहे हैं। क्यों यूज कर रहे हैं? क्योंकि अभी जो मैंने चीज तुम लोगों को बताई, बिकॉज एंटीना कैन ओनली ट्रांसमिट अ एनालॉग सिग्नल, it cannot transmit any digital signal. Okay, क्लियर है ये चीज? ये देखो di by dt means I current I is varying with respect to time. This is the only condition for the radiation. This is the only condition for the radiation. That's why after having R 0, 1, 1, 0, 0, 1, we applied ASK, PSK, FSK technique. That would be a such type of this thing, and we will do ASK, PSK, FSK according to this signal. This is our signal, and this would be our we can say the carrier type signal, and then we will have finally finally which we are having. Okay, so we want time varying signal for the radiation. Okay, so this is the main concept. Antenna cannot transmit the digital the direct current. Okay, time varying current is needed, and the second thing is the length. Okay, so now we will discuss how the length is crucial to the antenna radiation. Okay, two things are majorly involved. If any question is there, then you can ask. Okay, so the three things: if a charge is not moving means charge is not moving means there is no current, so there would be no radiation. Means charge is not moving, then there would be no radiation and there would be no current. So this is the null condition. And then second condition, if charge is moving with uniform velocity, means so there is 2 point. There are no radiation if the wire is straight and the infinite in extent. Okay, and there is radiation if wire is curved, bent, discontinuity, and terminated. Okay, so the second point is saying means your charge is having the uniform velocity, means the charge is not accelerating or deaccelerating. Okay, so if your wire is straight, there is no discontinuity. If there is no discontinuity, there would be no radiation. Okay, but if your charge is moving with a uniform velocity, then the radiation maybe takes place with the discontinuity, and the examples of discontinuities are curved, bent discontinuities, terminated or truncated. Okay, so curved means you can see like this is the curve, this is the bent. Okay, truncated means I will explain you what is the truncated, and I will also give you the truncated example when we will discuss the long wire antenna. Okay, several type of discontinuities, even all such type are referred as the discontinuities. Okay, and this is the terminated. Okay, so what is the main scenario? Means we are putting the discontinuities over there. You can think about the law of inertia, moment of inertia. Okay, all of you are aware with this thing. Okay, suppose I can uh, let me take.
So could you please explain second point again?
Yes, I'm explaining the same point. uh, how blank slide will come screen. Suppose this is a road. Okay, and a vehicle, suppose a car is moving there with 240 speed, 240 kilometer per hour. Okay, this is so fast. Okay, suppose here road ends and there would be a valley type, खाई type से कुछ है, ठीक है, यहाँ पर road end हो जाती है, and it is moving with a velocity of 240 kilometer per hour. What will happen if the path is ended here? Then it should be dropped down immediately vertically, but it is not happening due to the moment of inertia. It will go like this. Okay, So in the similar analogy, in the similar manner, radiation is taking place with the discontinuities of the antenna. With the discontinuities of the antenna. Okay, so the main thing in this equation, I have told you the current should be time varying. Okay, but in this case, if we are considering, so first of all you can take this case, if charge is oscillating in a time motion, then radiation even if the wire is straight, so that would be a condition for the radiation. So in this case, if we are having a uniform velocity, if we are having a uniform velocity and our wire is straight, then there would be no radiation. And if we are having a uniform velocity but we are having some discontinuities, so radiation can take place through the discontinuities. Okay, is it clear?
So what is the meaning of discontinuous here?
Discontinuity meaning is uh, like I have given you the example of road. Okay, means current is moving here and we are finding a discontinuity over here because the road is ended, so there would be the radiation. Okay, suppose the current is moving here like this, but here is the discontinuity, it is bent here, so from this corner, actually this radiation should be shown here. From this corner, from this discontinuity, the radiation will take place. Okay, it is bent
Okay,
here.
this point.
Okay, so in this similar manner, the current is moving like this and here is the discontinuity. You can see that discontinuity means the radius of this wire is changing, so current is radiating from this point, radiation is taking place from this point. Okay,
Okay, sir.
is it clear? So the thing is one thing, first of all we can see, if charge is not moving means there is no current, there will be no radiation. If charge is oscillating means in a time motion, and even a wire is straight, there would be the radiation. Okay, but if we will talk about this point, second point, if charge is moving with a uniform velocity means there is no acceleration or de-acceleration. In this point, in this third point, there is acceleration and de-acceleration. Okay, and radiation is taking place, but if the uniform velocity is there, so radiation will only take place with the discontinuity, at the discontinuity path, okay. We will talk about several type of discontinuities, like we are having a conducting sheet. This is a conducting sheet. Okay, this is a copper sheet, and what we are doing, we are this is a copper sheet and we are cutting out a slot. Means this is a discontinuity, so radiation will take place from this discontinuity. Okay, several type of discontinuities are there. Okay, truncation means this is something. What truncation is, in this figure you can say you are having a cylindrical rod over there, and you are just cutting out any portion, means you are just making it the semicircle. Means earlier you are having such type of circular rod, means then again you have truncated it horizontally. Now you are having only semicircular rod is there. Okay, it is like truncated. Okay, even you can truncate it from like this, you can truncate it with some curve. Okay, so radiation will take place. If we will talk about a sheet, this is the examples of wire antenna. If we are having the sheet, okay, now I am truncating its corner. This is also the example of truncation. So now our copper part is here only. Okay, so when we will move with the some examples, some more examples of the antenna, this discontinuity will be more cleared. So the thing is, the main thing is, two things are necessary. Two things are necessary. Number one, the current should be accelerating. Okay, and number two, discontinuity should be there, and at a particular length, discontinuity will be applied. So we will see in the several examples. The whole antenna course is there. I will explain in again and again. I will explain again and again in different examples of antenna. So here is the discontinuity, here is this part. Okay, so this thing will be cleared, more clearer to you in as we will move further with this course. Okay, so if there is any doubt, we can discuss. Okay, if there is no doubt, then we can move further. Okay, so I have shown you this figure. This section is representing the transmitter part. This section is the transmission line part, and this section is the antenna part. Okay, you can see a signal is coming in the sinusoidal manner through the transmission lines. You can see here is the plus, here is the minus, and this should be we can say this is the negative half and this is the positive half. Okay, okay, and when antenna structure is started, the signal is moving in forward direction in the similar manner according to the antenna structure. It is started to resonate, means signal is resonating, but still the signal have not left the antenna structure. Signal is still within the antenna structure. Okay, it will leave the antenna structure at the discontinuity. When discontinuity will be occurred, then radiation will be taken place. Okay, so this is the structure. So again, radiation happens. Okay, and how it will propagate in the free space, I will show you. Okay, so please look at this point, P0, P1 and P2. What are these points and how it will radiate? Means these points will be radiated like this, like this. Okay, the radiation is going on. This is the example. This is the example of dipole antenna. Okay, so what is happening here? We see in this example. Okay, so this A figure is at time t is equal to 0, means when your system is started. Okay, so we can see here is the P0 point. P0 point is here. This example is for t time is equal to 0. Okay, small t and capital T, small t is there. Okay, so and this is P1. So please see this figure. P0 is something here, P0 is something here, and P1 is here, P2 is here, P3 is here. Okay, as the time is shifted means now we are talking about time t is equal to t by 8. T by 8 means if we are talking about this one, this is t by 2, this is t by 4, this is t by 8. Okay, now you will see in this figure at time t is equal to 0, P0 is here, P1 is here. Now you can see P1 is shifted away from the antenna source, and here is the P0, and you will see some more radiations is there, some more radiations are emerging there. Okay, now if we will see at the time t is equal to t by 4, then you will see your p1 point is shifted here according to time. Your wave is traveling in the free space. Okay, and now p naught is here, p naught is here, and at time t is equal to 3t by 8, you will see p naught is here and p1 is shifted far away from your antenna source. Okay, and in the similar manner the wave will propagate in the free space, in the free space. Okay, and visualization this is the visualization how the wave is propagating in the free space. Okay, it is something like that. Suppose you are throwing a coin or something in a water, in a pond. Okay, what will happen? Suppose you are throwing a coin in water, it will suppress some layers of the water. Okay, and it will go down. Okay, at that time, at the same time, when the coin is suppressing the water particles, the other water particles will take that place. But when the coin will be dropped down into the downward direction, the suppressed water particles will revert back again, and those particles which have taken the place of that suppressed particles and which have taken the place of that cavity, okay, will be back down, and a wave will be created, that is the example of if you are throwing a coin in the water, and all of you have seen such type of waves running there. Okay, so this is the similar analogy. You can relate that water and coin analogy with the radiation, and it is going towards the end of that pond. Okay, so this is the scenario how the waves are propagating. Okay, we are going to discuss this in detail also. We will discuss again and again in 2-3 classes. I will discuss again and again how the radiation is taking place, what is the radiation mechanism. Okay, because this is the main concept, and you will understand this concept in 2-3 classes. Okay, so such type of radiation is there. Okay, second thing in this one, you can see when the field is emerging at the source, you are finding some color variations, means the red color is there, then the yellow one and green one is there. Okay, so according to this structure, according to this wave scenario, reasons field reasons will also be defined, means in the free space a typical EM wave is constructed, means E field is there, and in a horizontal plane H field will be there. Okay, as we have discussed in the EMT section, means E field, suppose this is X, Y and Z. So E field is oriented in ZY plane, vertical plane, and H field is oriented in XY plane, horizontal plane, means it is moving like this horizontally, and this is vertically. Okay, so such type of electromagnetic wave will be constructed after a distance from your source. Okay, so that reason, means after a distance, that reason is considered as the far field. Okay, we will discuss it in detail also. Far field. Okay, so far field is that field when your total EM wave is constructed and it will propagate with the same characteristics. If we will not talk about the amplitude of that wave, okay, it will propagate with the same characteristics in the free space. So that reason, when your wave is fully constructed, that reason is referred as the far field. Okay, and the two other fields are one is near field. Near field, you can say, when your waves are being constructed into the form of electromagnetic wave or in the form of transverse electromagnetic wave. Okay, that is the near field. And one more reason is near reactive field reason. Near reactive field reason, this is the reason, this is the reason close to the antenna surface, close to the antenna surface, where you can say, where you can say the field is being emerged or field is being radiated. Means it can be understand easily if we are taking the example of reception. If we are taking the example of reception, what is happening in the case of reception of any signal? What is happening there? Suppose a EM signal is striking on the antenna surface. You can relate that EM signal with the light energy, or you can say it is having a photonic energy. Means you can say a photon is striking on the antenna surface, and whenever a photon will strike on the antenna surface, it will release some amount of energy to h nu. Okay, so it will release some energy. Okay, I'm just telling an analogy with the light signal. Okay, so this is not exactly happening with the case of antenna. In antenna, EM signal is striking over there and it is making a current. Okay, so you can understand it by the this photon characteristics. Okay, so suppose a photon is striking on the antenna surface. Okay, it is releasing some energy. That energy will be transferred to the free electrons available on the conductor, because you are having a conducting antenna. Okay, so that energy will be transferred to the free electrons available on the conducting surface of the antenna, and after getting the energy, that free electron will start to resonate, will start to resonate. अगर आप जैसे बैठे हो, आपको एक बहुत सारी एनर्जी दे दी जाए, तो यू विल बी अनस्टेबल, sorry, for a time. Okay, so whenever there were free electrons, photonic energy will be transferred to that free electron, and those electrons will start to move. Okay, and the movement of electrons, it constitute a current. Okay, so you will achieve a current. Means at antenna surface you will receive a current. Okay, so that is the reverse process of the antenna at the receiving end. Okay, so we were talking about the near reactive field. So you can think about that small region just close to the antenna surface, just close to the antenna surface, where the electromagnetic energy is striking, and the conversion process between the electromagnetic energy and the electrical energy is happening. Sorry, is happening. Okay, so that is the near reactive region. Okay, so we can define the antenna regions in three manner. One is the near reactive region, second one is the near field, and the third one is the far field, where your complete electromagnetic signals have been constructed. Your complete electromagnetic signals have been constructed. That is the far field region, in which you have seen the transverse electromagnetic mode, in which E field was like that, H field was orthogonal to that field. Okay, that would be the far field region. Okay, so I think we should conclude our today's class at this point. So these are some odd antenna example, and we will start our dipole in tomorrow class. Okay, so from the same concept, we were talking about the length and the radiation mechanism, and these type of signals, what how this wave is going there. Okay, so the same thing will be continued in the dipole section. Okay, so tomorrow we will discuss how the radiation is taking place. Okay, so this concept I will show you which I was talking about. Okay, so I have already told you this will take, I think, 2-3 class to explain the radiation mechanism completely. Okay, so we will meet in tomorrow class. I think your timetable has been changed from tomorrow. Okay, so let me check your attendance, whether it is recorded or not. If you are having any question, then you can ask. Do you have any question?
So Navratan typed something in the chat, and there's a question.
Let me see. Navratan, see, there are two things. Means if we are talking about the components, means microwave components. Okay, there are two type of component. Means one is microwave component from which radiation is not required. Okay, we try to maintain the minimum radiation. Okay, radiation should not be there, but in the antenna radiation is desired, means radiation should be maximum. Okay, the first example is filters. Suppose if we are going to design the microstrip filters or filters, the main tendency to reduce the radiation should be minimum or should be zero. Okay, and in that case radiation will be considered as the radiation loss. Okay, but in the case of antenna, radiation should be maximum. Means we want the radiation, we want to enhance the radiation. Okay, that's why we are just degrading the path. Okay, and it is not something like that just we are degrading the path and there would be the radiation. Yes, of course, but there would be the uncertainty in the radiated frequency. Then what is the work of ECE engineer and the antenna engineer? We want the radiation as we desired, as we desire. Okay, we want our desired radiation at a particular frequency for the particular polarization. Okay, so it is not so simple to apply any discontinuity anywhere. Okay, so this is the just starting of the course, and later at the later stages you will realize how we are putting the different type of discontinuities in different type of structures, and how we are utilizing their benefits. Okay, so the thing is we want the maximum radiation. Okay, if any further question is there, then you can ask. Okay, so I think there is no question as usual. तुम लोग पूछते नहीं हो या फिर समझ में नहीं आता, क्या चक्कर है ये बताओ, या
सर
सब कुछ समझ में
आज
आता है?
तो सब इजी था।
समझ में आ जाता है, ऐसा तो हो नहीं सकता। हाँ, कुछ दीपक कह रहे थे।
नहीं सर, मैं बोला था आज का तो इजी था ना, तो आज तो क्वेश्चन नहीं होगा बच्चों।
अच्छा, नहीं कोई ऐसा वो नहीं है। देखो बस क्लास हम लोगों की इंटरेक्टिव होनी चाहिए, और द मेन थिंग इज कि बेटा आप लोग पूछते रहो क्वेश्चंस। मतलब जो इंटरेक्टिव रहते हैं बच्चे उनका तो अच्छा है, बट जो इंटरेक्टिव नहीं है आई एम कंसर्न अबाउट देम। ओके, सो आप लोगों को सबको पूछना है, सबको समझ में आना चाहिए। और कुछ बच्चों का ये रहता है, वो थोड़ा सा शाय होते हैं नेचर में, तो ऐसा मत सोचो कि बाकी सबको समझ में आ गया बस मुझे समझ में नहीं आया। तो ऐसा कुछ नहीं है, किसी को भी इतना अच्छे से समझ में नहीं आता, सभी बच्चे पहली बार पढ़ रहे हैं सब्जेक्ट को। ठीक है, तो ऐसा किसी को भी नहीं सोचना है, और फ्री माइंड से पूछा करो कोई भी क्वेश्चन। डिस्कशन होगा कोर्स में तो और भी चीजें सामने आएंगी। हो सकता है कि मुझे और 2 चीजें बतानी थी और वो दिमाग से स्लिप हो जाती हैं, कई बार कुछ हो जाता है तो वो ध्यान ना रहे, आपके क्वेश्चन से वो चीजें सामने आ सकती हैं, ठीक है। सो ऑलवेज आप लोग डिस्कशन किया करो ज्यादा से ज्यादा।
So just one thing, what's the difference between normal antenna and patch antenna? So Kanoge sir,
सॉरी, फर्स्ट वन वाज
these normal antennas that we are studying, this Hudson dipole and everything, and patch antenna.
is the form of conventional antenna. We can say the conventional antenna and the patch antenna. This is based on just the microstrip technology. Okay, just the microstrip technology is there, means uh, as you have designed your microstrip lines also. Okay, so this is based on the microstrip technology only. I will explain it when it will come in your syllabus in your part. Okay, so I will explain it in detail also. In patch, you are using a substrate, you are using two conductors on each side of substrate. Okay, so एक और चीज बेटा मैं तुम लोगों को बताना चाहता हूँ, देखो मेरा रिसर्च फील्ड एंटीना ही रहा है, ठीक है। तो वो आप लोग देखो मुझसे जितना ज्यादा ले सकते हो वो आप लोगों के बेनिफिट के लिए है। इट मे बी पॉसिबल कि कई बार हो सकता है कि मैं थोड़ा सा हाई चला जाऊं, क्योंकि एक चीज कई बार जब हम लोग पढ़ लेते हैं तो वो मुझे ऐसा लगता है कि ये तो समझ में आ जाएगी, तो आप लोग पूछ सकते हो बहुत ही निसंकोच होके, एकदम से माइंड में कोई क्वेरी नहीं रखनी है। और बस ये सोचा करो कि जब सर ये सब्जेक्ट पढ़ रहे थे आपके अंडर ग्रेजुएट लेवल पे तो मेरे को भी नहीं आया होगा समझ में, है ना। तो आप लोग उस लेवल पे मुझे समझो, और बिल्कुल एज ए जैसे पेपर के टाइम में, अभी तो खैर तुम लोगों का लॉकडाउन हो गया, तो हम लोग भी ग्रुप स्टडीज करते थे, एक बच्चा सेम क्लास का 4 बच्चों को पढ़ाता था, तो ये समझो कि बस आई एम योर सीनियर एंड आई एम टेकिंग दिस सब्जेक्ट, सो बी कंफर्टेबल विद मी, then in that case only you will grab the more things. Okay, I want to transfer 100% of my knowledge to you. Okay, so goodbye, take care, bye bye. कोई भी क्वेरी हो तुम मुझे व्हाट्सएप भी कर सकते हो, मेल भी कर सकते हो, कुछ भी कर सकते हो, ठीक है। गूगल क्लास में बना लूंगा कल की क्लास में, या फिर और अभी 1-2 हफ्ते हम लोग थोड़ा सा सब्जेक्ट को पढ़ेंगे, फिर देन वी विल स्टार्ट द लैब। वो मेरे ऊपर छोड़ दो, मैं अपने आप तुम लोगों का सारा शेड्यूल देख लूंगा, ठीक है। चलो ठीक है फिर, ओके, कोई क्वेश्चन नहीं है तो शुड आई एंड द मीटिंग? चलो
Yes.
ओके, बाय बाय।